Welcome to AI Podcast. I'm Marcus.
And I'm Elena. Today we're digging into a new AAAI paper called TrustUQA. Ready to brew this one down to the essentials?
Absolutely. TLDR, TrustUQA is a unified way to answer questions over different kinds of structured data, like tables, knowledge graphs, and even time-stamped knowledge graphs, all while keeping the reasoning transparent and checkable.
Unified and trustable sounds great, but what does trust mean here?
In this context, it means two things. First, less hallucination, because answers are computed from the data instead of being free-form guesses. Second, you can actually see the steps, like a trail of breadcrumbs you can audit.
Nice. Who's behind it?
Led by Zhang with Huajun Chen at Jiaoyan University and the ZJU Ant Group Joint Lab with collaborators including the University of Manchester.
Cool. So what problem are they solving that others haven't?
Most systems split into two camps. One, turn the question into a formal query, like SQL or SparkQL. Two, retrieve some evidence and let a large language model generate an answer. The first camp is accurate but siloed by data type. The second camp is flexible but can hallucinate and is hard to verify.
Right, I've seen that trade-off. Where does TrustUQA land?
It aims for the best of both. The key idea is a shared representation called a condition graph. Picture a subway map where stations are entities or values, and the lines are relationships or conditions. Whether your original data is a table or a knowledge graph, they convert it into this common map.
So instead of learning 5 different subway systems, the model learns one map. That's helpful. How do they actually ask the map a question?
They use a two-layer query strategy. First, the LLM writes a simple, human-readable plan using a tiny toolbox of functions, almost like a sketch. Then, a deterministic translator compiles that sketch into an executable query that runs on the condition graph.
Like an architect sketching the floor plan, and then a builder turning it into a precise blueprint.
Exactly. And here's the clever guardrail. If a step absolutely needs a judgment call, say comparing which number is larger in a way the graph can't encode directly, they allow a small LLM function for just that step. Otherwise, everything stays symbolic and auditable.
That helps the system stay grounded. Do they do anything to help the LLM write good sketches?
Yes. Before drafting the plan, the system pulls a few similar examples as demonstrations. Think of it as showing the model a couple of solved problems that look like today's question. That boosts consistency without hard-coding a single prompt for all tasks.
I like that analogy. What did they test this on?
5 benchmarks spanning 3 data types. 2 are table-based, 2 are classic knowledge graph QA, and 1 is a temporal knowledge graph dataset where facts change over time.
And they're not just comparing to weak baselines, right?
Right. They compare against other unified LLM systems as well as specialized models that are tuned for a single data type. The bar is decent.
So how did TrustUQA fare?
Broadly, it beat other unified frameworks and even achieved state-of-the-art on a well-known knowledge graph dataset called WebQSP and on the temporal benchmark. On the table dataset with trickier reasoning, it was competitive but didn't top the best specialized systems.
That tracks with the usual pattern. Unified models generalize, specialists still win on some niche tasks. Any insights from ablations?
2 big ones. Removing the 2-layer design hurt a lot, which suggests the plan then execute discipline matters. And turning off the dynamic demo retrieval also dropped performance, especially on the knowledge graph tasks.
What about those little LLM functions you mentioned? Do they overtake the pipeline?
Not really. They were used sparingly, and when they did appear, they tended to be less accurate than the purely symbolic steps. That's a nice signal that the more you keep inside the executable query, the more reliable things stay.
Let's talk trust a bit more. You said the system is more auditable. How does that feel in practice?
Because the LLM produces a short plan in a tiny function language, you can read it like a to-do list. Then the compiled query is deterministic, so if you run it again on the same data, you get the same answer. It's closer to a calculator than to a storyteller.
That makes sense, but trust has many facets. Did they tackle privacy or bias?
They mainly focus on verifiability and reducing data exposure by not shipping full tables to the LLM. Formal privacy guarantees and bias audits are outside the scope here, so progress on one dimension of trust, not the whole package.
Good to keep expectations realistic. Any other cautions you noticed?
A few. Some benchmarks have quirks, like ambiguity in certain knowledge graph datasets, which can inflate numbers if you're not careful. The pipeline also depends on a commercial LLM for the planning step, which means cost and some non-determinism. And errors often stem from entity or relation linking, that is, matching the words in the question to the correct nodes in the graph.
Classic mapping problem. If I ask about Paris, do you mean the city in France or the one in Texas?
Exactly. Strengthening that layer would likely lift results across the board.
I'm curious about the big picture. Is the condition graph just a research artifact, or could teams adopt it?
I think teams could adopt the pattern even if they implement their own graph. The recipe is appealing. Normalize your structured sources into one backbone, have the LLM produce a small checkable plan, and execute it symbolically. It's a planner-executor model that travels well.
If you were advising a company with mixed data, say spreadsheets, a product catalog, and a timeline of price changes, how would you apply this?
I'd start by mapping everything into a unified graph that encodes entities, relations, and timestamps. Then define a tiny set of functions your LLM is allowed to use, like filter, join, aggregate, and time window. Let the LLM propose a plan, compile it, and run it. Keep an audit log so analysts can inspect the steps.
And maybe cache those good demonstration examples so the model sees how your company's data is usually handled.
Exactly. Over time, you build a library of exemplars that nudge the planner toward safe, reliable patterns.
What's next for the research, in your view?
3 directions. First, broader evaluations on messier, real-world schemas, not just neat academic sets. Second, stronger entity and relation linking, perhaps with graph-aware encoders. Third, expanding trust metrics beyond accuracy, like measuring hallucination rates, data sent to the LLM, and user audit success.
I'd add cost and reproducibility. Teams will ask how to keep latency and spend predictable, and how to make runs deterministic for compliance.
Totally. Exploring open-weight models for the planning step and tightening decoding settings could help there.
Before we wrap, give me the elevator takeaway.
TrustUQA shows that if you treat the LLM as a careful planner and let a symbolic engine do the math, you can answer questions over very different structured sources with better transparency and competitive accuracy.
A planner with a calculator, not a storyteller with a hunch.
Nicely put.
That's it for today's AI podcast. If you're building QA over structured data, this paper offers a clean blueprint and a few practical guardrails.
Thanks for listening. I'm Marcus.
I'm Elena. See you next time.